Welcome, ladies and gentlemen, to the 2018 AP Calculus BC Multiple Choice Part A. We're going to be working over 30 questions. We have 1 hour, and a calculator is not allowed for this part. So I'm going to be showing you guys the solutions, sharing with you guys formulas, concepts, ideas, and also how to eliminate some answers that are not going to end up being the correct answer. Okay, let's go ahead and get started. Find a derivative. Okay, good. We're opening kind of easy. Here we're going to be using the product rule. It's the first times the derivative of the second. Take one away from the exponent and apply the chain rule. Plus the second times the derivative of the first. Okay. Now we just got to clean it up. Here the 1/2 is going to cancel with the 2. Those are gone. I'm going to go ahead and take my 2x plus 5 and I'm going to move it to the denominator. It's a radical since the power is 1/2. Okay, since this is not one of my answer choices, I am going to go ahead and get a common denominator. Put a 1 underneath and multiply times the square root of 2x plus 5. This will allow me to get the fractions together into 1. So my derivative is this x over the square root of 2x plus 5 plus the radicals cancel each other out in the numerator, giving us 2x plus 5 divided by the square root of 2x plus 5. And once I combine my fractions, I'm going to get 3x plus 5 in the numerator. So A. Okay, find the antiderivative. This was a little bit tricky because it's not one of the antiderivatives that we saw a lot in the regular school year, but I'll tell you what it is. The antiderivative of a to the x dx is going to be a to the x over ln of a plus c. It's basically like the derivative, but instead of multiplying by ln of a, you're dividing by ln of a. So just if you know that, you can see that the antiderivative is going to be c. Now, of course, there is a way to get the answer correct if you don't know what the antiderivative is, but it's going to take more time. And that's going to be by actually taking the derivative. So it's not going to be a, since the derivative would be a to the x ln of a, right? The answer. I would skip b if I didn't know my antiderivative, just because. Oh, wait, no, I don't have to skip it. I was going to say we have to use the product rule, but we don't. That's a constant, so you leave it alone. A to the x ln of a. And you can see that it's not the answer. You can go ahead and check C, right? Think about factoring the 1 over ln of 2 and just focus on the derivative of 2 to the x. Right here, the natural logs cancel, and that's where you can see you get your answer. And then D. I would probably do D last just because I'm going to have to use the quotient rule. And I didn't really have to do that in the first 3. So if it wasn't the first 3, then my answer was going to be D. 3. Find the limit as x approaches -7. Well, we actually see questions like this a lot, but a lot of times it's the limit as x approaches some random number of x over the absolute value of x, or it could even be the absolute value of x over x. We see that a lot. Graphs like that are basically just 2 straight lines. Here's the x-axis, here's the y-axis, 1, -1. So they usually just look like this, and that's because you're dividing x by x. If you're dividing something by itself, it's just 1, right? So when you think about dividing all the positive numbers, no matter what they are, 1 over 1, 2 over 2, 3 over 3, you get 1. That's why you get that straight line. But when you pick the negative x values, Well, let's see what happens. When you plug in a -1, a -2, or a -3, one of the numbers, regardless of what you have, is a positive, and then the other number is negative. So we end up getting -1. That's why you see that. This problem is exactly like that, except it's 7 units shifted to the left. So -7, that's where you're going to see the break 1. Then we have -1. And if you didn't know that, you can always make a table. For example, say you plug in -6. Well, -6 is going to get you 1 over the absolute value of 1, which is 1. You plug in 5. -5 plus 7 is 2. -5 plus 7 is 2, but it's the absolute value, right? So you get 1. You keep getting 1 and 1 again. And then you would do the same thing with values on the other side, such as -8, -9, and so on. But of course, we're going to get -1. Well, anyways, what's the limit as x approaches -7? Well, it doesn't exist. Because on one side, the limit is 1. From the left side, the limit is -1. The left-hand limit does not equal the right-hand limit. So there you have it. 4. Integrate. Okay. Since I see a function within a function, I'm already thinking this is going to be u substitution. So let's go ahead and pick the inside function as my u. My derivative becomes that. Oh, this should be du, not dx. And you could always rewrite it and call it 1/3 times x to the power of 2/3. Oh, dx. Let me check something real quick. Make sure my mic is on. I don't know if I turned it on. Okay, yes, it is. Good. That would have sucked having to redo the problems again. Anyways, we go ahead and isolate dx. And now let's go ahead and start our integral. We have the integral of u to the power of 5 divided by 6x to the power of 2/3. Take off the dx and replace it with what it's equal to. And right here, check it out. The x's cancel each other out. And 3/6 is going to give us 1/2. So we are going to go ahead and pull it out of the integral. Add 1 to the exponent. Divide by the near exponent. Plus c. That gives us u to the power of 6. So it was x to the power of 1/3 minus 4 divided by 12 plus c. There it is. A. Okay. Number 5. Okay, we have a table. And just by skimming through the problem, I see we're going to have to use a right Riemann sum with 3 subintervals. During the first 15 minutes, okay. I didn't really quite read the whole problem, but no, I'm going to have to do an integral. Plus, check it out, rate per minute. Oh, sorry, people per minute. It's a rate. Base times height, plus base times height, plus base times height. The first base is 5, and the height. Okay, people always, I see students making mistakes when they're choosing the height. We're using a right Riemann sum. So these 2 points make a rectangle in the graph. Pick the right one. Times 100 plus The next base is 5 times 75 plus 5 times 55. 500 plus 5 times 5 is 25, then 35, 36, 37. 5 times 5 is 25, 5 times 5 is 25, 27. Oh, I don't want to shift it up. So then here we have 5, 8, 1000 plus 75 plus 75. That's 140, 150, 1150. Okay, the answer is B. Oh, the first series questions. All right, ladies and gentlemen. Hope you guys are ready for this. What is the sum? Okay, since they're asking us what the sum is, most likely the series is going to converge. But there is an answer where it might not. So, because we'll see. So if you analyze this, it looks like the series is growing by the same amount, right? Look, the pi is staying constant. But what's changing? The denominator. It looks like we're multiplying by 1 over e every single time. But it also switches from positive to negative to positive. So for the first one, we multiplied by a negative e. To get to the third term, we are multiplying by a positive 1 over e. Oh, no. By a negative again. Because we have to go from a negative to a positive. And then we have to get back to a negative. So once again, multiplying by negative 1 over e. Well, isn't that a geometric series? When you multiply by the same ratio? You can even take this guy and kind of like figure it out from there. Because look, the sum of the series would be you can rewrite the series to look like this. Negative 1 to the power of n times 1 to the power of 1 e to the n. And then I'm just trying to show you the common ratio. I'm just working my way to simplify. This is, you don't have to do this. We already identified what the common ratio is. This is just another way to figure out what the common ratio is. And then you basically factor out the n. So there it is, your common ratio again. But once we figure it out, we just use arc 1 minus the common ratio. So the first term divided by 1 minus the common ratio. 1 plus 1 over e. You know what? Let's get a common denominator. E over e plus 1 over e equals pi over e divided by e plus 1 over e. And then that equals pi over e. We multiply by the reciprocal. These cancel. B. Okay. What is the limit as x approaches -1? Okay. This is the definition of the derivative. Which the formula is the limit as x approaches a is a value, in this case is -1, f of x minus f of a, x minus a. It's one of the versions of the formulas, okay? But you need to know that it's telling you to find the derivative. And in this case, they made it pretty easy because they told us what f of x is. So my derivative is 3x squared plus 1 squared times the derivative of the inside. But not only are they saying find the derivative, they're saying find f prime of a. So we have to plug in the -1. -1 squared is 1. 2, 4, 4 times 3 is 12. And then that's -24. Okay. Now, just for your notes, they usually ask you a question like this through another formula. They have also shown this. The limit as h approaches 0 of f of x of f of x plus h minus f of x divided by x by h. That's the other definition of a derivative, and it would basically ask you the same thing. But because here they're actually giving us a value, it would also look like this. But it's basically asking the same thing. It's saying find the derivative of f at a. Now the problem maybe wouldn't give you f of x in this case. Maybe it would give you f of x kind of in a hidden way. It would be like, so since they're using -1, oh, that would be very tricky in this case. But let's say it was something else. Let's say a was pi in this case. That way it's not too tricky. It would be pi squared plus 1 cubed. X. No, it wouldn't be like that. It would be pi plus h squared plus 1 cubed minus f of a. That's where we would have pi squared plus 1 cubed over h. I'm basically asking you almost the exact same question, except I'm not using -1, I'm using pi. Because then you can kind of try to retract the formula from here. Your job would be to figure out f of x, and you would be like, oh shoot, what's f of x? But then you would know, okay, a is pi, but normally a has to be x, so you can take this guy and kind of extract what f of x is by replacing pi for an x, and that would be your function. Okay, I kind of deviated a lot. Let's get back on track. Great. We have the graph of f double prime, which can be the graph of f. So we're going to have to read concavity. Okay, because we're given f double prime. F double prime is positive here and here, which means f of x would have to be concave up in those intervals. F double prime is negative right here, which means f of x would have to be concave down. Okay, we're looking for a graph with positive concavity, right? With concave up. The first graph, the first interval looks like that's concave down. Good, that's out. We can also eliminate. Oh, hold on, my screen is freezing a little bit. Doesn't want to scroll up. There we go. This one is also out because the graph is concave down. Good, so now we have two choices, and both of those have positive concavity. We're supposed to have a concave up graph all the way to the point. This is just an approximation. X equals -0.8, approximately. Let's say all the way to x equals 0.8. That's where the graph has to be concave down. Okay. Concave up, we get to 0.8. But here it's still concave up. It's looking like it's not going to be the answer. Let's check the other one. Concave up all the way to -0.8. Concave up, concave up, concave up. And somewhere here, concavity switches. right? And you can kind of see that the graph is now kind of opening downwards, concave down to approximately 0.8, and then concavity switches so that it's opening upwards. That's the winner. D. Okay, we have a differentiable function. What is the approximation using a tangent line? Check it out. We already have the point. Now we need the slope. The slope is given by x over y. So 8 over 2 is 4. The tangent line y equals m x minus x1 plus y1. Y equals 4, x minus 8 plus 2. And then we're going to use it to approximate 8.1. The series converges to which of the following? Oof. This one's a little rough, but we're going to have to use process of elimination. Okay, cosine. Cosine is even, sine is odd. And if you know your expanded series for cosine, you know that it starts with something to the power of 0, which is 1, minus x to the power of 2. And yes, it is over 2. Okay, I still need to master my series myself. Plus x to the power of 4 divided by 4 factorial. Technically, 2 is also factorial, but 2 factorial is just 2. Minus x to the 6, 6 factorial, and so on. Well, that's not the answer because it doesn't match what was given to me. Okay. Let's try D. I'm choosing the ones that I think are simplest. That's why I'm starting with C and D. With E, we're going to have 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. But because we have negative x squared, oh, this is just e to the x, right? Now we're going to replace the x, and we're going to substitute it with an x squared. So it's going to be x squared plus x squared squared plus x squared cubed. And that's going to be 1 plus x squared plus x to the power of 4, x to the power of 6 over 3 factorial. It's kind of looking like it, huh, guys? But, big but, we haven't even finished writing the expanded form because we're still missing the negative right here. So that negative is being multiplied to the x's. So now we're going to multiply the x squared by a negative. In other words, multiply the terms by a negative, and that's going to make everything negative. So that's not it. Okay. So now that leaves us with 2 choices. Okay. Let's try B. I don't want to get my words to be too messy, so maybe I'll try to write small. So remember, sine, if cosine is even, sine is odd. So sine of x, it's going to start with something to the power of 1, which is going to be x. Then it's minus x cubed over 3 factorial plus x to the power of 5 factorial of minus. But then this one, we're going to have to multiply by an x now. So x, sine of x, would be x squared minus x to the power of 4, x to the power of 6. It's not looking like it, ladies and gentlemen. It's not looking like it. Look, the term with the power of 4 has a 3 factorial underneath. Okay, so that brings us to the one that's actually the answer. So first, here's cosine. Remember, cosine is even. 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial. This is a good opportunity for you to write out your series as well and practice them. Plus sine of x, which is even. Odd. So x minus x cubed, 3 factorial plus x to the power of 5 factorial, and so on. But now we have to replace the x for x squares. So cosine of x squared is going to be 1. X squared is this. X squared to the power of 4 is, and I'm going to stop right here. But we got to do the same thing with sine. X squared cubed is x squared to the power of 5 is this. And if you add them up, we get 1 plus x squared minus x to the power of 4 over 2 factorial. Stay somewhere. Oh, wait, is this even the answer? Let me check the answers real quick. Oh, shoot, I don't even have it. Let's try to see. Let's see. Oh, I think I did make a big mistake. I think the answer was D here. Let's go back to D, because if I continue this process, then I was going to get minus x to the power of 6 divided by 3 factorial plus x to the power of 8 divided by 4 factorial plus x to the power of 10 factorial. And yeah, I mean, it looks pretty similar to it, except some of the signs are not right. Let's go back to D. I see that in my solutions I wrote the answer was D. So we have this. And then if I let me see, let me think. Negative. Okay, I'm gonna have to get back to you guys on that one because I wrote that the answer was D. And at this point, I think I just need to get the video out there. So I'll come back to number 10. Okay, number 11. The integral of x cosine of 2x. Okay, here we have a product. And when you see a product and use up fails, because use up will fail, look, u would be 2x, the u would be 2. The x here wouldn't cancel out. So when you have a product rule and use up fails, you're going to have to use ultraviolet voodoo. So we're going to pick U and we're going to pick dV. U is going to be something that can easily be derived, and dV is going to be that something that can be integrated. So U is going to be X, and the derivative is going to be 1 dx. dV is going to be cosine of 2x, and then the antiderivative is going to be sine of 2x times 1/2 times the reciprocal of the derivative. So u v minus the integral of v du. And this is where the dx comes into play because we still have to integrate. So we have 1/2 x sine of 2x. Okay. The derivative of the antiderivative of sine is negative cosine times the reciprocal of the derivative of 2x. And let's not forget the plus c. Plus 1/2 times 1/2 is going to be 1/4. Okay. D. Okay. Number 12. Oh, this mess up? Let me. Oh, it's messing up. We have to derive it with respect to x. So it's going to be 3 minus secant squared of y times y prime is equal to 0. We're going to go ahead and add the secant to either side. The secant with the y prime. And then we're going to divide by secant. Since my answers are not this, then maybe the secant has to be converted to a cosine squared. And there it is. 3 cosine squared of y. B. 13. Which of the following graphs is the solution to the logistic differential equation? If you remember your logistic differential equations, you don't have to think about this one too much. A logistics differential equation looks like this, and it's capped off. It's capped off by a limiting value, L, and in this case, L is 500. But just by the shape of it, it's D. Not only that, it meets the initial condition. It says that at 0, the y value is going to be 100. Well, that's it. What is the absolute minimum? Okay. Absolute minimum. That means we need a derivative. We need to make that derivative equal to 0. And we have to solve for x. But here we get cosine of x equals sine of x. And that, ladies and gentlemen, you're going to have to know your unit circle pretty well. When does cosine equal sine? At pi over 4. And because we have a limited interval, that's it. That's pi over 4. So to find the absolute minimum, we don't actually have to do the number line. We just have to evaluate the endpoints and the critical points. So we have to find y of 0, which is cosine of 0 minus sine of 0, which is cosine of 0 is 1, so that's negative 1. And we also have to do pi over 2, the other endpoint. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, but there's a negative in the front. So once again, we get negative 1. Now pi over 4. Cosine of pi over 4 is the square root of 2 over 2. Just don't forget the negative in the front. Sine is the same thing. This gives us negative 2 radical 2 over 2. The 2's cancel. And we get negative radical 2. And of course, the square root of 2, it's 1 point something. So the answer is C. Line segments. If g of 0 is equal to 1, what is g of 3? Initial condition. We need to evaluate. That means we should be using this formula. Plus f of a, but in this case, I'm going to call it g of a. So g of 3 is going to be the integral all the way to 3 plus g of 3. Sorry, not g of 3. We need the initial condition here from 0. And the y value of 0 is 1. So we have to find the integral from 0 to 3, which is this part. One quarter pi r squared plus 1/2 base times height. The base is 1, the height is 2, plus 1, the initial condition. Here we have 1/4 pi times 4, leaving us with pi. The 1/2 and the 2 cancel each other out. So we get pi plus 2. Partial fractions. So this is going to be the integral of a over 1 minus 6 plus the integral of b over 3x minus 5 dx. We just have to figure out what those are. So pretend I don't have the integral right now. I would have to multiply both sides by my common denominator, which is 1 minus x and 3x minus 5. And technically this side, same thing. 1 minus 6, 3x minus 5. So what happens? When you do that, the denominator is gone. But on the right side, for the first fraction, the 1 minus x cancels, but that's going to leave us with 3x minus 5. And for the second fraction, we're left with 1 minus x. There we have it. Now, there's 2 zeros that we have to test. So what are my zeros? One of them is 1, and the other one is 5/3. So let's start by testing the 1. When x is equal to 1, what happens? Well, I get 1 plus 3 equals a. 3 minus 5 plus b times 0. 4 is equal to negative 2a. So that means a is negative 2. What happens when x equals 5/3? Well, we get 1 plus 3 times 5/3 equals a times 3 and 3 times 5/3 minus 5 plus b. Why did I write 5? b 1 minus 5/3. Okay, that one gets a little tricky because it's a fraction, but it's not too tricky. The 3's cancel. So 1 plus 5 is 6. The 3's cancel. 5 minus 5 is 0. So that part is gone, right? And then we have b. 1 minus 5/3, or 3/3 minus 5/3. It's negative 2/3. Multiply by 3. and divide by negative 2. We get negative 9. So now I go back to my integral, and I have negative 2 divided by 1 minus x plus negative 9 divided by 3x minus 5. And even though we got most of the hard part, it's still a little tricky. When you find the antiderivative, it's going to be negative 2 ln of 1 minus x. But don't forget to multiply the reciprocal of the derivative. The derivative here is negative 1, but the reciprocal is still negative 1. Okay. Now the natural log of 3x minus 5. Same thing. The derivative here is 3. Multiply times its reciprocal. So we get 2 ln of 1 minus x minus, oh, it's not going to be minus 9. It's going to be minus 3 ln of 3x minus 5. A. Okay, for number 17, we have a snowball. It's melting, but it's maintaining the shape. We have a decreasing volume of a constant rate of 8 cubic centimeters. At what rate is the radius decreasing? At the instant when the radius is 10. And luckily they give us the formula for volume. That's good. That's pretty nice of them, right? dv dt equals 4. When you bring the 3 down, it cancels with the other 3, right? Now we're taking the derivative with respect to t. Yes, with respect to t. So that means we have to derive r as well. dr dt. Now I have negative 8 equals 4 pi 10 squared times dr dt. I'm going to divide by 4. And then I'm also going to divide by 100 pi. And that's going to give me negative 1 over 50 pi. That's the rate. That's the rate of the radius of the sphere. But look at the question again. It says, at what rate in centimeters per hour is the radius of the snowball decreasing? So decreasing already implies negative. So it's decreasing at a rate of this. You can't say it's decreasing at a rate of negative 1 over 50 pi. That's a double negative. They cancel each other out. Okay. Find the derivative. Okay, here you have to know your fundamental theorem of calculus. And if you do, this question is pretty easy. The derivative is cosine. This is what happens. Cancel the integral, and then you plug this in. X cubed squared. But then you have to multiply times the derivative, 3x squared. So now we get 3x squared cosine of x to the power of 6. Oh, and then you got to plug in pi. That's going to be 3 pi squared times cosine of pi to the power of 6. Oh, just kidding. It wasn't a pi. It's the square root of pi. The square root of pi squared, the square root of pi to the power of 6. Yeah, I was wondering why I didn't see my answer there. So that cancels. And remember, the square root, it's like saying to the power of 1/2. So when you raise it to the power of 6, you just multiply these two. Here we go. D. What is the slope of the line tangent to the polar curve? Okay, this is something you need to remember. The slope of the polar curve is going to be dy over dx. Okay, big shocker, right? Except when you're dealing with polar curves, you got to remember that y equals r times sine, and then x equals r times cosine. I'll tell you why at the end, in case you want to just see the solution. So I'm going to have to derive those. So dy d theta divided by dx d theta. I got to use the product rule. So it's going to be the first times the derivative of the second. Plus the second times the derivative of the first. Same thing. The first times the derivative of the second plus the second times the derivative of the first. Now we're going to plug in pi. And we're also going to plug in r. This is what r is. So 2. Maybe I should just plug that in first. Times cosine of theta plus sine of theta times, we also need to know what r is, right? Or r prime. R prime is going to be 4 theta. Divided by r, which is 2 theta squared times negative sine of theta plus cosine of theta times r prime. Now we can go ahead and plug in pi. That's going to be 2 pi squared times cosine of pi, which is negative 1. Sine of pi is 0. So the whole thing has become 0, right? Negative 2 pi squared times, sine of pi. Sine of pi is 0. Plus cosine of pi. That's negative 1. Times 4 pi. A lot of things canceled out here. We get negative 2 pi squared in the numerator. In the denominator, we get negative 4 pi. One of the pi's cancels. In the negative 2, in the negative 4, they reduce to a 2. So there you have it, pi over 2. Okay, now for the extra mini lesson. If you forget what these guys are, think about right triangle trigonometry. Whatever angle you have, some random angle, it's going to take you to a point, and you're always able to build a right triangle. Now this is x, this is y, and this is the radius of the circle. So think about doing cosine of theta. That would be your adjacent over the hypotenuse, and all you got to do is really get x by itself. Oh, no, I don't want you scooting over. So multiply by r. And that is the equation for x. At the same time, if you do sine of theta, it's the opposite over the hypotenuse. We can multiply the r to both sides, and there is your y equation. Okay, in case you forget them. Okay. 20. G is a twice differentiable function. It's increasing. If g of 0 equals that, which of the following must be true? Okay, well, they told us it's a twice differentiable function, which also means that that's continuous. Okay. It's also increasing. So that means it's not going to be decreasing. That gives us two possibilities. 0, 20, 10, 220. And because it's increasing, it could be concave up. It could be concave down. Or it could be straight. but it's not going to be decreasing. And of course, you can do a combination of everything, right? At this point. So, which of the following must be true? The derivative must be zero. Hmm. Well, it doesn't have to be. It's not zero here, right? In the first option, the derivative is never zero. In the second option, the derivative is never zero. In the third option, the derivative is never zero. But sure, it could be zero. But it says which of the following must be true. So can the derivative be zero? Sometimes, not always. Like here's here's how it could be zero. You increase, you briefly stop, like it looks like you have a horizontal tangent, but then you keep going, but you never decrease. Like yeah, it could be zero, but it doesn't have to be true. The derivative must be 20. That's talking about the mean value theorem, I think, where the average rate of change must equal the instantaneous rate of change. 200 divided by 10, that's 20. So the average rate of change must equal the instantaneous rate of change. And yeah, that actually has to be true because the function is continuous and differentiable. The conditions were met. Can the concavity be zero? Well, I gave you some examples where it doesn't have to be zero. In the first example, the concavity is not zero. The concavity is positive. In the second example, the concavity is negative. In the third example, yes, the concavity is zero. So sometimes, but not always. D, the second derivative is positive. Well, look at example 2. It's not always going to be positive. So there you have it. B, by the mean value theorem. Find this integral. Looks complicated. When you do integrals, of course you could just do them. That's the most straightforward one. You can do area under the curve, but that's not going to work here. You can do u sub. That's not going to work here. You can do integration by parts, which is your ultraviolet voodoo. That's only if you have a product rule. So no. You can do partial fractions, but for that one, the denominator has to have a greater degree, and the denominator must have a greater degree. So I'm just going to say d to the power of n. The numerator, oh, I should probably say something else. I'll say a. And then the numerator, we have to have a smaller degree. B must be less than a. So no, partial fractions can't work. But there's also this trick. It's kind of an old trick. Just straight up simplify. Can we simplify before we integrate? And you're like, how can I simplify that? That's not factorable. Well, nobody said anything about factoring. We can just do long division. We're going to multiply by 6x to get 6x squared minus 12x. And when you subtract, these cancel. We have negative 4x minus negative 12. That's going to be 8x. Then we're going to multiply by a positive 8. And when you subtract, these cancel, and that's going to be negative 9. So it doesn't have to simplify all the way through. Your integral is going to be now 6x plus 8 plus 8x minus 9 ln of x minus 2 plus c. Okay, A. Okay, so we have already done 21 questions, and the only question that I got stuck on was one of the series, so not too bad. And talking about series. Let's hope this one doesn't trip me up, because I already owe you guys a question in class. Which of the following statements about convergence is true? Okay. A. It converges by the comparison test. False. This one diverges. So we're going to call this A of n. And every other series that's given to us, we're going to call it B of n. B of n, B of n, B of n, B of n. Now, ln of n plus 1 is less than n. So when you put them in the series as a fraction, that means that A of n should be greater than B of n. Does that make sense? I hope that makes sense. This number is larger than this. And because that's larger, that means the fraction is going to be smaller, right? So, come on, pen, don't freeze on me. Okay. And because this one diverges, this one would also have to diverge. That's false. B. This one converges by the comparison test. Okay. So same scenario, basically. A of n, which is the given series. We know that fraction is going to be greater than. We know that's going to be greater than B of n. Okay. Okay. The question is, does B of n converge or diverge? B of n is a P series, and it converges because P is greater than 1. And if this one converges, does A of n converge? Well, it's greater. A of n is a greater series. It could converge, but it could also diverge. So, not necessarily. Oh, it's the next one, not a circling. Okay, back to 1 over n. The original series has a smaller denominator, which means the series has to be bigger. And 1 over n diverges because it's harmonic. So if this one diverges, the small one, if the small one diverges, the other one has to diverge. And is that what it's saying? The series diverges by the compare. Yeah, that sounds like the correct answer to me. Let's go ahead and check the last one just in case. The original series, its denominator is smaller, which means the value of the fraction is greater than B of n. And this one, we already said that it converges because it's a P series. If this one converges, does A of n have to diverge? No. It could diverge, but it could also converge. So there's no conclusion right there. So C. Okay. The length of the curve is given by what? Oh, okay, this one is going to be easy if you guys know your formula for length of the curve. Now, it's not a parametric curve, right? It's just a regular one. So it's going to be the integral from A to B of the square root of 1 plus f prime of x squared dx. So the integral from 0 to 1 plus f prime squared, so cosine squared dx. D. Okay. Come on, scroll down. Oh man. Too too much for the computer to handle. Starting to get a little laggy. Let's go. Nope, not that. Oh, man. Okay, there we go. X is x sine of x squared. F of 0 equals 0. What are the first three terms of the Maclaurin series? Maclaurin series means that it's going to be centered at 0. That means C is equal to 0. A Taylor polynomial. A Maclaurin series is a Taylor polynomial. It's like your tangent line, right? Except the y1 goes first, and instead of saying y1, we're gonna say f of c, and c is whatever we're gonna be centering it at. M is a slope, so it's a derivative. X minus x1, but we're gonna say c in this case. And then you take the second derivative, x minus c squared divided by 2. I'll give you one more. F triple prime of c times x minus c cubed over 3 factorial. Now, technically, there's a pattern to this, right? The derivative matches the degree, and it matches the number that's in the denominator. Now, for the first two terms, we usually don't write factorial because 2 factorial is just 2. And then we also don't say to the power of 1 divided by 1 factorial, but that is the case. Now, it says write the first 3 non-zero terms. So let's see. Oh, but you know what? We don't even need to know this formula. We're just going to go ahead and we're going to write the series for sine. Sine of x. Sine is odd. Because technically we do build it by going through this whole thing, but we want to save that time by knowing our series. So something to the power of 1, x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial minus this and so on. So we get this series by going through the Taylor polynomial sequence, but again, we can skip that. Now, from here, we're going to go ahead and plug in x squared. This is very similar to the last one where I couldn't do it, huh? X squared cubed is 6. X squared to the power of 5 is 10. And then x squared to the power of 7 is x to the power of 14. And then it's telling me to find the derivative. So dx of sine x squared. By finding the derivative, you just take the derivative of the series. I'm going to stop right there because we only won the first 3 terms. Just a matter of simplifying. 3 factorial is actually 6. When you're dealing with 5 factorial, 5 times 2 is already 10, so we're going to cancel the 10s out. But that's still going to leave me with a 4, a 3. So that's going to be 12. So do we have this in the choices? Oh, they're trying to trick me. Okay, because I almost selected B. But then I just saw one little detail. Oh my God. We got the Maclaurin series. We're not trying to find a derivative. Oh my Lord, sweet Jesus, here. Backtrace. It says that if you get sine of x squared, that is the derivative already. Look at this. That's already f prime. All this is f prime. But we want to get the Maclaurin series for f. Oh man, they got tricky. So we have to integrate it. So if I integrate it, then I'm going to get f of x. So It's the opposite. We're going to add 1 to the exponent and divide by the new exponent. Add 1 and divide by 7. Add 1 and divide by 11. So that's going to cancel the first two. They almost got me with this one. Okay, just a matter of simplifying here. 3 factorial, that's 3 times 2. 3 times 2 is 6, and 6 times 7 is 42. 5 factorial. 5 times 4 times 3 times 2. 20 times 6 is 120. That's not going to be a pretty big number. But let's see. Yeah, I can already choose my answer. It's D. I gotta be careful with those questions. Okay, 25. Which expression gives total area for the shaded regions? And we have polar curves. Well, first off, I want to figure out which function is which. So why don't I try plugging in theta is equal to 0. Let's go ahead and do it for the first one. R is equal to 1 minus cosine of theta, which is cosine of 0. So this graph has a starting point at 0, which is here. Now the other one, it's 1 if you plug in the 0. It has a starting point at 2. That's over here. So this one is 1 plus cosine of theta. And then the other circle, which is this one. What's not even a circle, huh? For that one, that's 1 minus cosine of theta. Let me wait for this to fix. Okay. Now, first off, the formula for area. It's the area from alpha to beta, or the integral, of 1/2 r squared d theta. And our polar function is very symmetrical, right? So I'm technically only going to take this area, and then I'm going to multiply it by 4. If I take a straight line, which represents my terminal side, this terminal side is going to start rotating. It's going to start rotating, right? And as it rotates, let's say that's pi over 6, pi over 4, pi over 3. You can already start kind of seeing which area I'm starting to create first. Because we're creating the area between the terminal side and the curve in R. So look at which area I'm capturing. I'm capturing this guy. So you should be working with this function first. Okay. So that was pi over 6. And then it's going to keep rotating. It's going to keep rotating by some angle theta all the way until it gets to pi over 2. All the way until it gets here, pi over 2. And then we have captured all this area. So we're going to go the integral from 0 to pi over 2 of 1/2, and then 1 minus cosine theta squared d theta. But that's only one of the 4 sections, right? So multiply by 4. That's the area. If you multiply it by 4, you can take the 1/2 out of the integral. We get 2. Because 4 times 1/2 is 2. So there it is. C. The table above gives values of a continuous function. Okay, that sounds like it's going to be important. If f has exactly 2 critical points on the open interval, which of the following must be true? Okay. Well, okay. The graph starts at 10, 5. Then it goes to 11.2. Then it goes to 12.3. Then it goes to 13.6. And finally to 14.5. Let me do that a little better. Because it increases all the way to 13.6. And then 14.5. So because we saw a decrease, and then we see an increase, and then we see another increase, and then we see another decrease, that already kind of implies that it has two critical points, right? Looking at my graph, I see that we have a horizontal tangent here, and we have a horizontal tangent here. So now we can't have any more critical points. So f of x has to be positive for all x in the open interval from 10 to 14. That's not true, because I can make a very similar graph. If I start at 10.5, I could technically dip below the x-axis and then come back up to 2. Yeah, I can come back up to 2 and then keep going back up to 3. If I go back up to 3, then I go up to 6, and then I come back down to 5. That's still technically two critical points, but I gave you negative values, so no. F prime of x exists. We were told that the function is continuous, but we were never told it was differentiable. So those critical points could be corners. Right? B. I'm going to stick with my original drawing. 5.10, 11.2, 12.3, 13.6, 14.5. So this is still technically a critical point, and this corner is technically a critical point. But again, they are corners, so the derivative will not exist. The derivative has to be negative from 10 to 11. The slope has to be negative from 10 to 11 because we're decreasing. Well, no, not necessarily, because we never knew what happens at 10.1, 10.2, 10.3. We just know that we get to 2. It could be 0. Say you start at 10.5, and then you're supposed to go to 11.2. So you could be decreasing, but then it says it has to have two critical points. So let's come up with a counter example here. The derivative has to be negative for all x. The slope has to be negative. My goal is to come up with a counter example. The slope would have to be negative, 0, positive. Okay, I'm starting to have I'm a little bit stuck on that one. So let's try and go ahead and check with D. The derivative at 12 can't be 0. Well, if it is 0, that would create an additional critical point. And if we have an additional critical point, we wouldn't have exactly 2 now, would we? Because that one we would have 3. Let's use this space for that one, for D. I start with my point 10, 5. Then I go to 11, 2. Then I go to 12, 3. See, but if it's 0, let's say we have a momentary moment in time when the derivative is 0, and then it continues increasing to 6, back down to 5. I would now have 1 critical point, 2 critical points, 3 critical points. We can't have the derivative be 0. So it sounds like this one has to be true. Again, being 0 creates a third critical point. But C, a counterexample for C, the derivative is less than 0 for 10 to 12. Oh, here we go. C, the same example I used for A. We start at the point 10, 5, and then we have to end at the point. Oh, wait, does that disprove it? Yes, it does disprove it. We end at the point 11, 2. 10, 5, 11, 2. Technically, this example only does have 2 critical points, right? Because my minimum is now down here. But the slope is positive for this small segment. So the slope has to be negative? No, not necessarily. So there we go. 27. Which of the following could be the slope field? Okay. Oh, sometimes I don't even read the whole question, and that's a bad habit. But look, G is a function that's always positive, no matter what Y value you plug in. Okay, keep that in mind. So why don't we start by plugging in x equals 0, which is basically any value on the x-axis. It doesn't matter what I plug in for y, right? Because it's going to be g of y is going to be positive. So dy dx is going to be, so we said 0. 0 minus 1 is negative 1. And then g of 0 is going to be positive. So my slope is going to be negative. That is going to eliminate b since the slopes. Sorry. I don't like it when it does that either. The slopes along the y-axis, they're positive. So look at all this. And we just said we have to get negative slopes. And that also eliminates C. Because I can see that we have some positive slopes here. Okay. Now, what's the difference between A and D? The difference is here at x equals negative 1. Look at all those slopes. And on D, those slopes are all negative. So we're going to try that. We're going to plug in x equals negative 1. My derivative is going to be negative 1 squared times g of anything. It could be g of 0, it could be g of 1, it could be g of 2. It doesn't matter because it's going to be positive. So that's going to be 0. And that only happens at A. Okay. What are the values of P for which the series converges? Well, technically, if you see it in an integral, you could also write it as a series. Right? The series from n is equal to 1, because that's where it starts. all the way to infinity of 1 over x 3p plus 1. That is technically a p series, right? We just need this exponent to be greater than 1. Let's solve for p. So p has to be greater than 1/3. Wait, no, what am I doing? 0. P has to be greater than 0. C. $29. The temperature of a solid at time t is greater than 0 is modeled by H, and it's increasing according to the differential equation. Which of the following must be true? So it looks like we're going to have to try to solve for H. Okay, and to do this, we're going to go and do separation of variables. I'm going to multiply dt to both sides. And then I'm going to divide by that factor right there. So 2h plus 1 dh is equal to technically 1 dt, right? You don't have to write the 1, but that's what's left over. Then I take my antiderivative, ln of 2h plus 1. Just don't forget to multiply by the reciprocal of the derivative. Equals t plus c. Now, I'm just trying to get one of the answers right there. So I'm going to multiply both sides by 2. And that's going to give me 2t plus c. You're not getting a 2c. It's just a different constant. But this is enough right here to get my answer. That looks like it's D. Okay. Now, the last question. Yes. The first time I was doing this question, I thought I had it, but then the answer wasn't one of my choices. So I forgot. I told myself I needed more time to think about this. So I'm gonna owe you number 30. We'll discuss that in class. Research it yourself too. See if you guys can figure it out. In the moment I got stuck, and I thought it was the only question, but apparently I also got stuck in question number 10. So I guess I owe you 2 questions. But thank you very much. We'll do those later together. Have a good day. Rest up. Study. The AP test is like right around the corner. Once we finish it, we'll be done. We'll be free of our responsibilities, at least in math class, for a brief moment. But yes, study. Good luck. Hasta luego.